Good afternoon, everyone. My name is Arman Vesh, and today I will be presenting on the topic working with Claude Opus 4.6 and building AI agent for B2B SaaS. Engineering Guide for Production Grade AI Agent Systems. Claude Opus 4.6 Model Overview. It is the most advanced model in the Claude 4.5 family. It is designed for complex reasoning, advanced code generation, and multi-step analysis. It is best suited for high-stakes enterprise tasks and prioritizes accuracy and depth over speed. The Claude model family comparison. It has different models for different workloads. Trade-off between intelligence, speed, and cost. Here is a table for a short summary for the family description. Key insight: model routing in production. Avoid using a single model everywhere. Route requests based on task complexity. Example strategy is simple classification is used by Haiku, general workflows Sonnet, and complex reasoning Opus. Reduces cost without sacrificing quality. Claude Opus 4.6 capabilities. Extended thinking, large context window, advanced tool use, code generation, agentic workflows, and safety and alignment focus. Here is the overview of the Claude Opus 4.6 capability matrix, features, matrix, and prompting. Extended thinking in Claude Opus enables deep and multi-step reasoning. Model reasons internally before responding. It is useful for financial analysis, legal document review, complex debugging, and workflow planning. It also trades latency for reasoning depth. When to enable extended thinking? You should enable for complex logical or mathematical tasks, architecture or design decisions, and cross-reference document analysis, and when to disable it for simple lookups, classification tasks, low latency chat use cases. Some best practices for context management are prioritize relevant context, summarize long histories, chunk large documents, use prompt caching for repeated systems prompts, combined with RAG pipelines. Tool definition and function calling. Tools are defined using name, description, input schema. LLM selects which tool to call and with what parameters. It enables safe, structured system interaction. AI agent architecture for B2B SaaS. Enterprise AI agents require layered architecture, clear separation of concerns between user interaction, intelligence, data access, and safety. It improves scalability, reliability, and governance. Here is the five-layer architecture design for your reference. It has the client layer, orchestration layer, intelligence layer, data and tools layer, and the safety layer. The five-layer agent architecture, the interface layer is the user interaction. Orchestration layer is the coordination and planning. Intelligence layer is LLM reasoning. Data and tools layer is APIs, DBs, and services. Safety and guardrails layer is controls and validation. Memory architecture in AI agents. Agents use multiple memory tiers. Each tier serves a different purpose. It balances context, performance, and cost. Here's the memory tier, the scope, implementation, and the use cases for the following: working memory, session memory, episodic memory, semantic memory, and procedural memory. Agent development lifecycle. Building AI agents goes beyond standard software development, requires clear scoping, continuous evaluation, production monitoring. Lifecycle design for enterprise reliability. Here's the reference for agent development lifecycle. The define, then build, then test, then deploy, then observe. The phase one is clearly define what the agent should do and what the agent must not do. Scope narrowly for reliability. Define persona or boundaries. Required tools and data sources. Success metrics such as accuracy, latency, and cost. Edge cases and failure paths. Phase 2 is build core logic. System prompt is the most critical artifact, defines agent identity, behavioral rules, constraints, output format, and prevents unsafe or undefined behavior. Phase 3 is evaluation and testing. Evaluation must be multidimensional. It covers quality, safety, reliability, and cost. Here is the eval type, botted test, implementation, and target. Unit tests, prompt evals, trajectory evals, adversarial regression, A and B tests. Phases 4 and 5 is deploy, monitor, and iterate. Use canary deployments, control rollout using feature flags, implement fallback strategies, log the prompts, responses, and tool calls, then continuously monitor quality, cost, and health. API integration and cost optimization. Sustainable AI systems require efficient API usage, cost-aware design. Cost optimization is not optional in B2B SaaS. Poor integration leads to high latency and unpredictable spend. Here's the reference for API integration and cost optimization. The integration patterns are synchronous, streaming, background queue, fan out and fan in, cascading models. Streaming integration pattern streams partial responses to users. It improves perceived latency. It is ideal for chat interfaces, long running tasks, and enables early user feedback. Prompt caching. It reuses static system prompts and reduces token usage and API cost. It is best for repeated workflows and multi-turn conversations. It monitors cache hit rates. Cost management checklist. Prompt caching for repeated context. Route to cheapest capable model. Batch API for non-urgent tasks. Summarize context beyond 50K tokens. Set per use and per feature budgets and monitor cost per interaction daily. Prompt engineering for B2B SaaS. B2B agents. Prompt engineering is a core engineering task. It defines agent behavior, constraints, output structure. Poor prompts lead to unsafe behavior, inconsistent responses, and higher costs. Multi-tenant prompt safety. Critical in enterprise SaaS, it prevents cross-tenant data leaks, prompt injection attacks, and the techniques include instruction hierarchy, input validation, and output filtering. Error handling and resilience. Implement retires with backoff. Handle rate limits and model failures. Route to basic fallback models when needed and avoid hard failures in user-facing systems. Observability and monitoring. Monitor system health continuously and track latency, reliability, quality, cost, and safety. Here's the table for metric key indicators and the alert threshold for latency, reliability, quality, cost, safety, and usage. Multi-agent orchestration patterns. Used when task complexity increases and multiple specialized agents collaborate, it improves modularity, accuracy, and fault tolerance. Here's the table for the same. Pattern description and when to use for router agent, pipeline, supervisor, debate or verify, fan out, and in. Security and compliance in AI agents. AI agents operate on sensitive enterprise data. Security must be built in by design. Focus on access control, data protection, cost abuse prevention. There is a table for the same. Threat vector impact and mitigation for prompt injection, data leakage, tool abuse, cost DOS, and hallucination. The key takeaways are Claude Opus 4.6 enables enterprise-grade reasoning. The AI agents require architecture, safety, evaluation, and cost control. Production readiness is as important as intelligence, and multi-agent systems scale better for complex workflows. Thank you.